Welcome to section 5.5. We're going to be talking about multiple angles and product of sum formulas. So in order to work on this section, you need to use these double angle formulas listed at the top. So when we're going to write these solutions, we're going to write them in the general form and from 0 to 2 pi. The general form is a little bit different for these, just the way the angles are kind of set up. Still use the same process, just going to see some special cases that happen as we go through. So we have 2 cosine x. We can leave that as is. Now sine of 2x, we need to replace it. So what we have here is 2 cosine x, and using the double angle formula, it's going to be plus 2 sine x cosine x equals 0. Looking at the common factors here, we can factor out a 2 cosine of x, and when we do that, we get 1 plus the sine of x equals 0. Now that it's factored, set each factor equal to 0. 2 cosine of x equals 0. 1 plus the sine of x equals 0. So when we solve, we divide both sides by 2, and we get the cosine of x equals 0. Subtract 1, you get the sine of x equals negative 1. Now, thinking about our unit circle, when the cosine of x equals 0, that's when x equals pi over 2 and 3 pi over 2. When the sine of x equals negative 1, that's when x is 3 pi over 2. So now, our solutions from 0 to 2 pi is going to be pi over 2 and 3 pi over 2. We only need to write it once. It's being included there with the cosine and with the sine. Now, when we write this in the general form, think about where these are located on the unit circle. Here's pi over 2 and here's 3 pi over 2. What happens is they are just pi units apart. So our general form would be pi over 2, x equals, pi over 2 plus n pi. And that gives us all of the solutions for this equation. Next one, cosine of 2x plus cosine of x. Now we have some freedom with the cosine of 2x. You kind of want to think about which one would be best to use. They're all just rewrites of each other using the Pythagorean identities. So looking at this, cosine 2x and cosine of x. I want to use something with cosine in it. So I'm thinking let's use the middle one. So we have cosine of 2x. We're going to write that as 2 cosine squared of x minus 1 plus the cosine of x equals 0. So what we have here, when we rewrite it, 2 cosine squared x plus the cosine of x minus 1 equals 0. And we can factor this. Let's say that the cosine of x is y. So we have here, when we rewrite this, thinking algebraically, is 2y squared plus y minus 1. So when we factor that, we get 2y and y. So we have a y plus 1 and a 2y minus 1. So when we substitute our cosine of x back in, we get 2 cosine of x minus 1 times the cosine of x plus 1. Now that it's factored, we set each factor equal to 0. 2 cosine of x minus 1 equals 0. Cosine of x plus 1 equals 0. So we add 1, we get 2 cosine of x equals 1, and we divide by 2. So cosine of x equals 1/2. And for the other one, cosine of x equals negative 1. So now, when cosine is a positive 1, that's going to be in quadrants 1 and 4. So to get that 1/2, we have our pi over 3's. So for us to be in quadrant 1, it's pi over 3. In quadrant 4, it's 5 pi over 3. Now for the cosine of x equaling -1, that's on our quadrant angle. That's going to be at pi. So for our answers from 0 to 2 pi, we're going to get x equals pi over 3, 5 pi over 3, and pi. Those are our answers from 0 to 2 pi. Now, when we write this in general form, thinking about the unit circle where these angles are, here's pi over 3, and 5 pi over 3 is here, and here is pi. Now, what happens is these are a 2 pi over 3 apart. And because they're 2 pi over 3 apart, when we generalize it, we can actually just write x equals pi over 3 plus 2n pi over 3. So that gives us all of the solutions. And you can see pi over 3 plus 2 pi over 3 is 3 pi over 3, which is pi. There's our other solution. And then when we add 3 pi over 3, which is pi, plus 2 pi over 3, that brings us to 5 pi over 3, our other solution. And then when we add 5 pi over 3 and 2 pi over 3, that gives us 7 pi over 3, which is the same as pi over 3. So it's just going to keep bringing us around. All right, let's go to problem number 3. Sine 2x, so we have to rewrite using our double angle formula. So sine 2x, we're going to have 2 sine of x cosine of x times the sine of x equals the cosine of x. So we're going to get everything onto the same side. So we're multiplying, so we're having 2 sine squared of x cosine of x minus the cosine of x equals 0. So we multiplied the signs and we subtracted the cosine x from both sides. Now we have a common factor, the cosine of x. So cosine of x times 2 sine squared x minus 1 equals 0. It's factored, set each factor equal to 0. Cosine of x equals 0. 2 sine squared x minus 1 equals 0. So we add 1, 2, sine squared x equals 1. We divide by 2, so sine squared x equals 1/2. And then we take the square root of both sides, so the sine of x equals plus or minus, and now the square root of 1 over the square root of 2, when we rationalize that, we multiply by root 2 over root 2. So we get root 2 over 2. Now, when cosine of x equals 0, for our solutions, it's at the quadrant angles. It's going to be when x equals pi over 2, 3 pi over 2. When the sine of x equals plus or minus root 2 over 2, now for the positive, we're in quadrant 1 and quadrant 2. For the negative, we're in quadrant 3 and quadrant 4. Now to get that root 2 over 2, that means we have a pi over 4. we're in all quadrants. So pi over 4 to get us into quadrant 2, 3 pi over 4. Quadrant 3 is 5 pi over 4, and then 7 pi over 4. So for our solutions from 0, try writing that again, from 0 to 2 pi in that first unit circle, pi over 2, 3 pi over 2, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Those are our solutions in the first unit circle. Now, when we think about generalizing these, the general form, think about the unit circle. So for our pi over 2 and our 3 pi over 2, that's here and here. Those are pi apart. And then if we think about our pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, that's where those are. Now, there's no nice way to connect all of them. So for our pi over 2's, x equals pi over 2 plus n pi. Now, for our pi over 4's, they're a pi over 2 apart from each other. So x equals pi over 4 plus n pi over 2. And that would give us all of the answers in the general form. And just to kind of show you, pi over 4 plus. Now, pi over 2 is the same as 2 pi over 4. So when we add that 2 pi over 4, we're at 3 pi over 4, our other answer. We add another 2 pi over 4, we're at 5 pi over 4. And then we add again, we're at 7 pi over 4. So if you can see, it's accounting for all of those answers. Let's go to the next page. Use the double angle formula to rewrite the equation. So 4 cosine squared x minus 2. So looking at this, I can factor out a 2. So it's 2 times 2 cosine squared x minus 1. Now, as I'm looking at that, 2 cosine x minus 1, that looks like the middle double angle formula. So what we can do is y equals 2, and now instead of writing 2 cosine squared x minus 1, that's the same as the cosine of 2x. So y would equal 2 cosine 2x. That's rewritten using the double angle formula. Just used it backwards. All right, use the following to find sine of 2 theta, cosine 2 theta, tangent 2 theta. Now they're telling us that the cosine of theta is 5 over 13th, and theta is between 3 pi over 2 and 2 pi. That's telling us that we're in quadrant number 4. Cosine, adjacent over hypotenuse. So adjacent is our 5, 13. You can use the Pythagorean theorem and find out that the missing side would be 12. Now we are in quadrant 4, so that y-coordinate has to be a negative. Now for the sine of 2 theta, using our double angle formula, that's 2 sine theta cosine theta. So it's going to be 2 times. Now the sine of theta, opposite over hypotenuse, negative 12 over 13. Cosine of theta is 5 over 13. So you're just multiplying the fractions. 2 times negative 12 times 5 is negative 120 over 13 times 13, which is 169. So there's the sine of 2 theta. For the cosine of 2 theta, we have any of those 3 that you want to use. There's no wrong one to use. Let's do cosine 2 theta equals cosine squared theta minus sine squared theta. Any of the three would work. So for cosine squared, cosine is 5 over 13. So it's 5 over 13 squared minus negative 12 over 13 squared. So that's going to be 25 over 169 minus 144 over 169. So when we subtract 25 minus 144 is negative 119 over 169, which is nice. We already had our common denominator. There's the cosine of 2 theta. And then finally, the tangent of 2 theta. Using the double angle formulas, right there, it's going to be 2 tangent theta over 1 minus tangent squared theta. So it's 2 times. Now the tangent, opposite over adjacent, negative 12 over 5 over 1 minus, 1 minus negative 12 fifths squared. So our goal is to get one fraction on the top. So when we do that, we multiply, remember it's a 2 over 1, we get negative 24 over 5 over 1 minus, when we square the negative 12 fifths, we get 144 over 25. Now that's a 1 over 1, so our common denominator would be 25. So you multiply by 25 over 25, so you get negative 24 over 5. And that's 25 25ths minus 144 25ths. So it's negative 24 fifths over negative 119 over 25. Now remember, we don't divide fractions. We multiply by the reciprocal. Keep change flip. Negative 24 over 5 times the reciprocal. Negative 25 over 119. I can simplify before I multiply. The 5 becomes a 1. The negative 25 is going to be a negative 5. And just multiply the numerators. Negative 24 times 5 is positive 120 over 1 times 119, which is 119. And there's the tangent of 2 theta. Just using those double angle formulas and then working with the fractions. Now for the last one, we're deriving the triple angle formula. The sine of 3x is the sine of 2x plus x. So now this is our u and our v. Using that formula we talked about before, the sum and difference formulas, remember, the sine of u plus v is the sine of u cosine v plus cosine u sine v. So we're going to use that. So we have here, it's the sine of u, which is 2x, cosine of v, which is x, plus the cosine of 2x times the sine of x. And now we just use our double angle formulas. So for sine of 2x, that's the 2 sine of x cosine of x times the cosine of x plus, now instead of writing cosine of 2x, I'm going to use the one with just sine in it. So it's going to be 1 minus 2 sine squared x times the sine of x. Now we just kind of keep simplifying. 2 sine of x cosine x times cosine of x is 2 sine of x cosine squared x plus, when we distribute the sign, we get sine of x minus 2, and sine squared times sine is sine cubed x. Now, I can combine like terms a little bit, but I also don't like that there's a cosine there. Now, cosine squared, remember, sine squared x plus cosine squared x equals 1. So if I subtract sine squared x from both sides, I get cosine squared x equals 1 minus sine squared x. So I'm going to rewrite 2 sine of x, and that is going to be now 1 minus sine squared x plus the sine of x minus 2 sine cubed x. A lot of just simplifying here. So when you distribute, you get 2 sine of x minus 2 sine cubed of x plus the sine of x minus 2 sine cubed x. So now when I combine my like terms, 2 sine of x and another sine of x is 3 times the sine of x. Negative 2 sine cubed is negative 4 sine cubed x. And that's actually the triple angle formula. That's how you would find the sine of 3x. And that was really kind of just showing how we can rearrange and use previous knowledge with the double angle formula and the sum and difference formulas to rewrite. Okay, that's it for chapter 5. Thank you. See you next time.